Okay, students. So now let us go to the solved example on functions topic. Clear? So in the previous class, we have studied the definition of function and what must be the condition for a relation to be an function. Clear? So now let us go to the solved examples on functions topic. Okay. So here this question is, let n be the set of natural numbers and relation R defined on n, that is nothing but natural numbers, such that R equal to set of order pairs x comma y such that y equal to 2x comma x comma y belongs to n. N means natural number. What is its domain, codomain and range? Is this relation is a function. Okay. So here they have given one relation. Already you solved the problems in the relation topic of writing the relation in roster form. After that you also calculated domain set. Also that you also calculated codomain set and range. Okay. So now here also they are asking the same question as you studied in the relations topic, but little bit extension of that question. What is that? Is this relation is a function they are asking. Okay. So as you all know, here the very important thing is this set R. If we crack this R, or if we decode this R, or if we understand this R, then everything is over. Clear? So in this particular problem, we have to decode this R, or we must write this R in roster form, or you must understand that R. Okay. Here what happens, again in the last class, the last problem of exercise 2.2, there we have written the domain and codomain are infinite set, they are integers. Clear? You can see that problem and this problem are 90% similar. Okay, because see this, R equal to set of order pair x comma y such that y equal to 2x. See, R equal to set of order pair x comma y such that y equal to 2x, x comma y belongs to n, x comma y belongs to n. Okay. So that means x, the first element of order pair, the same element is also going to be what? Domain. Y, the second element of order pair, is going to be the range of the relation. Clear? That is also what? Natural number. Clear? Okay, that means here what happens? Write its domain, codomain and range. They are asking. Domain is x, that is natural number set. Codomain is what? Codomain is the given set. For example, if A and B are the two given sets, B will be the codomain, as you all know, because for Cartesian product A cross B are very essential. For relation, that Cartesian product definition is very essential. Clear? As we all studied, the second set, the complete second set is called codomain. That means in A and B, B is codomain. Clear? And the collection of first elements of the order pairs is what? Domain. Okay. And the collection of second elements of the order pair is what? Range. This all we have studied in the previous class of relations. The same thing here you have to apply. If you collect the first elements, it will be the domain. If you collect the second elements, it will be the range. And if you see the set which is given, that will be the codomain. That means, see here, x belongs to what? N. That means domain is natural number set. Domain is natural number set. Natural number set, or you can say just as n. Clear? Next, codomain. codomain is again a natural number set. Codomain is again a natural number set, or you write it as n. That is the symbol of natural number set. Clear? Why is domain is natural number set? See, x belongs to what? Natural numbers. So that's why domain is natural number set. Codomain, you see, the relation is defined on n. That's why they have given only one set to define the relation. That means they are applying Cartesian product with the same set, n cross n. They are calculating. So for that reason, the same n is going to be the codomain. Now range. See, range is what? The second element, y. Y is equal to what? 2x. X is what? Natural number. Natural number starts with what? 1, 2, 3, 4, 5. If you go on putting the values 1, 2, 3, 4, 5, so on here, what you are going to get? Multiples of 2. 2 into 1, 2. Y will be 2. 2. If I put 2 here, 2 into 2, 4. If I put 3, 2 into 3, 6. If I put 4, 2 into 4, 8. That means this y is going to be an multiple of 2. As you all know, multiple of 2 is even. Okay, so range is even natural numbers. Even natural numbers. Why it is even natural numbers? See here, y will be equal to what? 2, 4, 6, 8, 10, 12. That means multiples of 2 you are going to get. You are not going to get any negative numbers. So here all even natural numbers are going to be there for this y. 2 will come, 4, 6, 8, 10, 12, so on. That means even natural numbers are going to be there in your range. Okay, so these three things are over. The next thing very important is, see, is this relation is a function? Is this relation is a function? So whenever you are finding a relation is function or not, as I said, every elements of domain must have unique image in codomain. Is this clear? So then how to check this? Every time you can't have those problems. There must be one trick to solve that particular type of problems. So what is that trick? See, in exams also, if I am telling the statement, very important one, please clearly understand it. Whenever this type of statement is asked in your exam, that is this relation is a function? That means you have to answer either yes or no. Are you getting my point? You have to answer as either yes or no. That is what the target of answer. Clear? So in exams what happens? If it is yes, you have to answer with definition. Please remember this. If your answer is yes for this particular question, then you have to answer it with definition. Okay, suppose if your answer is no, you have to give one example. Which type of example? Through that example you must say that that particular statement is going to be false, or it is no as your answer. This is very, very important, because so many students lose marks in exam in this type of problem. They will write answer as no, but for satisfactory answer for that no is example. That example the students are not going to write. Then they will not get a single mark. Are you getting my point? So for that's why here is this a relation is going to be a function means first you have to check with some arrow diagram or some mapping that you know. Okay, what is that? See, This is your rough work. Please don't write it in exam. Okay? Clear? This thing will be your rough work. This is domain, this is codomain. We have to check this relation is going to be function or not. So domain is what? Natural number set. So I will write natural numbers 1, 2, 3, 4, 5, 6, so on. Clear? Next, codomain is what? Natural number set. I will write natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, so on. Clear? So now, what I will do? I will do mapping. If I put x value as 1, that is from domain, what will be y value? 2. Clear? So 1 maps to 2. Next, 2 maps to 4, 3 maps to 6, 4 maps to 8, 5 maps to 10, 6 maps to 12. So see here, with this 6 examples, that means these are the 6 examples. Okay, whenever you see these examples, if I go on continuing like this, 1 has 2 as the image, 2 has 4 as the image, 3 has 6 as the image, 4 has 8 as the image, 5 has 10 as the image, 6 has 12 as the image, 7 will have 14, 8 will have 16, 9 will have 18, 10 will have 20 as their images. Okay. So what here we are observing, each and every elements are having the unique images. That means all the images are different. Don't worry about these things. Already I have explained yesterday. What I have explained, these kind of elements can remain in codomain. They will not create any problem. But if this type of elements remain in domain, then that is not going to be a function. Okay. But here no element is going to be remain, because every element will have an image, because this is also natural number set, this is also natural number set. From this there is a image, from 2 there is a image. If you go on solving, every natural number from the domain will have an unique image. This you will understand by solving this rough work. Are you getting my point? So now you got an idea as your answer. What is an idea of your answer? Yes, it is going to be a function. Yes, it is going to be a function. Means how to write? With definition you have to write. See how to write the function. The third question, see, I will write, yes, it is a function. Yes, it is a function because every element of domain has every element of domain has unique image. This is your answer to say it is function. Clear? Suppose if it is not function, whenever you are solving this type of example, there you will come with one example. From that you are going to get an answer as no. But to say no, there are no that type of examples here. So that's why I will write it as yes. So therefore it is a function because every element of a domain is having a unique image. That's over. Clear? Suppose if you get an example, you have to choose that example and you have to write in your answer. Suppose your answer is no. If it is yes, you have to write through the definition. If it is no, you have to take that example and you have to write in your answer. Whenever we come across with that kind of example, with writing such type of examples in your answer, you will be more clear, but you must have this idea. Okay, if you have this idea, if you come through that example, then it will be very simple for you. Okay, so please keep that an idea. Clear? I will go to the next question. Okay students, now let us go for the 11th example, that is, examine each of the following relations given below and state each case giving reasons whether it is function or not function. Okay, so they have given three relations. You have to check these relations are going to be function or not. As we all know, each and every element of the domain must have unique image, then only it is going to be function. Clear? So if I check R, the first one, what are the domain elements? 2, 3 and 4. Clear? So 2, 3 and 4 are having the images as, see here, 2, 3, 4, 1, 2, because there are only two elements. So that's why I will write 1, 2. 2 maps to 1, 3 maps to 1, 4 maps to 2. Okay. So many number of students will get confused with these two arrow marks. Okay, no problem. 2 is having unique image, 3 is having unique image. The images can be same. Are you getting my point? See, 2, 3, 4, 1, 2. 2 as 1, 2 as 2. This is not unique because 2 has two different images. Clear? Here 2 and 3 are having the same images. This will not create a problem. What definition tells? The elements of domain must have unique image. The images can be same. They have not told that images cannot be the same. They only told every element of domain must have unique image. So that's why 2, 3, 4 are having the unique images. That means they are having one images. Clear? Here 2 has two different images, but here 2 has only one image, 3 has only one image, 4 has only one image. See this, here 2 has two different images. So this is not function. This will be function. Clear? So that's why we can clear this confusion that 2 has one image, 3 has one image, 4 has one image. Therefore, this is going to be a function. Clear? So clearly, every element of the domain have unique image. Therefore it is function. Clear? So as I said, please pause the video to take down the notes. Don't wait for PDF notes. In mathematics, it's very tough to give PDF notes. Clear? Because it's not theoretical thing. Clear? Here we have to solve the problem. Why particularly me not provide PDF note means, by giving PDF notes, student will had those problems. Are you getting my point? But by writing like this, they will have a practice. Suppose while writing this type of problem, if you get any doubt, what you will do? You will rewind the video and you will see. Are you getting my point? Suppose if you don't get any doubt, what you will do? You will play the next video. That means your doubts will be clarified clearly by writing the notes, by pausing the video, not by the PDF notes. Clear? So that's why I never produce or I never give a PDF notes to any students. I just tell them to pause the video and take down the notes. That's very important method. In class, what you will do? In regular classes, what you will do? We will write a problem on board, you will take it down and we will go for the next problem, right? That's how you have to do in online classes also. You pause the video, you take down the notes, okay? So if you get any doubts, you can rewind. Still more you are getting the doubts, you can ask, okay? So that's why please pause the video and take the notes, okay? Let us go for the second one. 2, 2, 3, 4. See here. 2, 3, 4. You make this 2, 4, 3. Okay. There also you are having 2, 3, 4. 2 maps to 2. 2 maps to 4. From this only you can tell that it is not a function. Why? 2 has 2 different images. 2 has 2 different images, hence it's not a function. Remaining elements no need to check. You got in one example, that's enough. As I explained in the previous problem, to say no, you give a small example, that's enough. Clear? So while writing the second question, clearly, or you can say not clearly, it is not function. It is not function because 2 which is in domain is not having unique image, or you can also tell the 2 element which is in domain has 2 different images, okay? Or you can tell 2 which is in domain is not having unique image, or you can tell 2 which is in domain is having 2 different images. Like this you have to give an example. Here if you write this diagram, it's very good because the answer is no. If you write this arrow mark, then it's very good and fine. So with that, you write this arrow mark. But with first one, there is no need of this arrow mark. Clear? For the second one, you write this arrow mark. Okay? 3 maps to 3, 4 maps to 4. Clear? So you write this arrow mark with this particular answer for the second one. Because whenever the answer is no, example is important. Whenever the answer is yes, definition is important. Clear? So that's why you write this arrow diagram with this particular answer. So answer will be very much clear for the evaluator. Okay? And the third one, you try it on your own. Okay? Try to answer the third one as yes or no. If it is yes, you have to write with the definition. If it is no, you have to write with the arrow diagram with the example. Clear? So no problem. 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, 5 maps to 6, 6 maps to 7. Already I got the answer, but I will not tell. You try on your own and check you are going to get the correct answer or not. Anyways, it's a solved example. Already I have given one of the PDF of your textbook of chapter 2. You see that in that there will be the answer. If you get the correct answer, no problem, it's very well and good. That means you are getting the concepts very clear. If you are getting no as your answer, you have a doubt with this type of arrow mark and the definition of function. There you have to go for the revision. You have to go for the revision of functions definition. You have to go the revision for this type of arrow marks which I have already explained in the previous session. Clear? Okay, try to answer on your own for the third one.